Welcome SMARS fans, how are you doing on this amazing Sunday evening? Do you want to build your own robot? Don't know where to start, what you'll need or how to do it? Then you're in the right place. Stick around and I'll show you what else I've been working on at the moment, my InMove robot. So I'll show you guys some of that later on. Okay, so my name's Kevin. Come with me as we learn robots, bring them to life with code and have a whole load of fun along the way. So this week we'll be continuing our look at the quad robot, and just turn my volume down, I'm getting a horrible echo there. And we'll be wiring up and maybe looking at the Raspberry Pi if we have time as well. So let's get over to the keynote. Just bear with me while I press the right button for that. Okay. Okay, so our goals, if you remember from last week, we're looking at building our SMARS Quad. We've got all the parts for that we printed out last week. We'll be making our SMARS Walk controlled with a web interface, so that'll be the culmination for this week, and looking at the SMARS Lab software next week. And we also want to take it much further, so we want to see if we can make our SMARS Robot see and process, detect faces, objects, that kind of thing, using something called openCV, computer vision. And we want to make our SMARS talk and also respond to voice commands as well. So we'll be looking at how we can do those things with Python. So this week, the electronic parts that we'll need, you need a Raspberry Pi Zero, an SD card with Raspbian Buster installed, I think it's now called Raspbian OS, a PCA 9685 board, the SG90 servos, you'll need 8 of them, 4 for each side, some DuPont connectors. If you're going to battery power it, which I'm not on this build, you'll need 2 18650s and also the camera module as well, the Raspberry Pi camera module. So if we have a quick look at the overhead shot, you can see over here we've got these parts laid out. So we've got a Raspberry Pi Zero inside here. If I just open up this case, you can just see there it is. We have the PCA 9685 board, that's one there. I've got another one just there as well. We'll come to one of the issues that you can come across with these, but we have a solution to that. We have all the 3D printed parts. We've got some of the servos. I put some of the servos already in these just to try and save us a bit of time today, so it's not just me putting servos into pieces of plastic for the entire hour. And we've also got the rangefinder module there. We may or may not use that in this build, but we'll put it on there just for completeness. And I think that's it for the wiring parts. We might need some DuPont connectors as well, so I'll grab some of those. I've got some of these just off camera here. We just need 4, I think they're female to female connectors, so we'll include that as well. Okay, back to the screen share. Nope, not the screen share, sorry. That's my desktop. The keynote. And let's have a look what we need to do next. So where do you get all these electronic parts from? So sometimes you might think, well, what is the exact board that you're using there? So one of the reasons I created smarsfan.com was to bring together all the information that we need for building our SMARS robots. So that includes things like the instructions on how to build them, as well as what parts you need. And I've even set up a small online store there with exactly the parts that you'll need if you want to build along. So you'll find the exact motor shields, you'll find the exact Bluetooth modules, PCA 9685 boards, rangefinder modules, servos, the lot. So that's where to get the electronic parts from. And as I said, this week we're going to be putting together these 3D printed parts along with the electronics. We're going to be setting up the servos so that the servo horns are correctly set, and I'll explain what that means in a minute. If we have time as well, we'll have a look at Raspberry Pi and getting that set up correctly, and getting SMARS Lab for Raspberry Pi installed as well. So they're dependent on time, just how long it takes to do this. So some of the things we need to look at today then. This PCA 9685 board allows us to connect up to 16 servos to our computer, whether it's an Arduino or a Raspberry Pi, just using 2 pins, a clock and a data pin. So that's a lot less pins than if we had to wire these things up directly to the Arduino or Raspberry Pi. We would need to have at least 8 pins to control them. And the PCA board as well will also help with power. So at the very top of the board there is, I don't know if you can see that. I can't see that moving on the screen. At the very top of the board, there's a power, a ground and a voltage in, and it can regulate that somewhat as well. So what we need to do then is decide which order of these pins we are going to use for our leg arrangement and our feet arrangement. So if we're consistent with this, it just makes it a lot easier when we come to write the software and to debug the software. If we just randomly shove them in any order, it just makes it a little bit trickier later on. So this is the configuration I've gone with. So on pin 0, they start at 0 on these PCA 9685 boards. The very left hand side is pin 0. So I usually use the front left leg with that one, and the number 1 I use the front left foot. So the leg is the thing that swings around, the foot is the one that goes up and down. And you can see then number 2 is the back left leg, number 3 is the back left foot, number 4 is the back right leg, number 5 is the back right foot, number 6 is the front right leg, and number 7 is the front right foot. And I've colour coded them as well, just to try and help illustrate that. Okay, so let's go to let me just check that's all good. So if we go to the next screen, so on the Raspberry Pi, when we plug this in, wait for that to catch up there, to the PCA 9685 board, as I said, there's only 2 pins that we need to connect up there. It's the green and the blue pins, which are going to pins 5 and 3. So 5 is the data clock, and number 3 is number 5 is the clock, number 3 is the data. So I think I've just got a typo there on number 5. That should see is it a typo? No, it should say SCL, sorry. So these are the things that help us wire this up. So what I'll do is I'll actually start just by connecting them up first, because this one I'll forget later on. So what I'll just need to remember there is it's pin 5 for the data and pin 5 for the clock, 3 for the data. 5 for the clock, 3 for the data. So let's go to our overhead for a second. So what I'm going to do is I'm going to connect this up first of all. So this cable that I've got here conveniently has got a red and a brown for voltage and ground, and it's got an orange and a yellow. So I'm going to use the orange one as our data one, the yellow as the clock, and the red and the brown as the voltage and the ground. So ground is that pin there, the very outside one. And this is important that we get it's the second pin from the bottom on this board, not the bottom one. If we use the bottom one, what will happen is as soon as we try and draw any current on these servos, it'll probably just reset the Raspberry Pi because it tries to draw too much current from it. So it's important we use that other pin there. So what I'm going to do now is get the orange cable, and that's going to go to the data, the SDA, and the yellow one is going to go to the clock. So I'm just going to plug that into the clock there as well. Just get that on there. There we go. Okay, so that's that part of the wiring up done. I'm going to leave that just for now. We don't need to plug it into the Raspberry Pi just yet. And let's go back to our keynote. And what else we're going to look at. So the configuration for each leg. Just waiting for that to catch up. Should be displaying a different screen now. I'm just going to quit that and restart it. I've ordered a new MacBook Pro from Apple. The one that I'm using at the moment to do various things is struggling, shall we say. It randomly works and randomly doesn't work in very unspecific ways. It looks like to me like a memory fault of some kind, but you run the memory checks and it works fine, so I'm not sure what's going on there. What I'll do if this continues to misbehave is I'll just switch to this computer instead and just load up the keynote on there. So just bear with me while I do that. Let's go to here. Okay, let's just load up iCloud on my other machine. still misbehaving. So I'm actually using a combination of a PC, a Mac and an iPad at the moment to manage all this. Right, there we go. So Keynote, and if I just load up the correct one, I can share that screen momentarily. There we go. Quad build along part 2. Okay. Just need to go to share screen, and I think I just need to make one setting change, and then we can carry on. So change capture and GDI. Okay, there we go. So I now go to that, and let's get rid of that, and we are on the this is the one I'm looking for. Okay, can we hide the navigator? Yes, we can. Good. Right, so hopefully you can see that fine. So what we've got going on here is this is a sort of overhead view of the quad robot, and what we're looking at here is what is the degree of freedom that these servos need to spin round. Because if I get this one that I've already built here, if I try and move this servo, it'll clash with the head that's just here. So I need to make sure that this servo only goes to a certain degree and then returns to a certain degree as well. And again, because there's another one next to it, I basically want it to go from this sort of 90-degree angle all the way up to actually 9 degrees. So this little table I've got on screen here shows me that I've got 9 degrees as the minimum angle for the front left leg, and 90 degrees is the maximum angle that I want this to go to. And for the front right leg, it's not the exact same. You think it might be, but because these are actually completely symmetrically mirrored, it's going from 90 degrees to 180 degrees. So it's actually going from 90 to 180. And then the back left leg is going from 90 to 9 degrees, and the back right leg is going from 9 to 90 degrees. Sorry, 90 to 180 for the back left leg, and 9 to 90 for the back right leg. And there's also a thing that's called inverted, and that's because the servos, if you think about the orientation that these are in, it can be very different depending on where it is on the robot. So some of them are actually swiveled around, and I can write the same code and just have a little flag to see, is this sort of upside down, or is it not upside down, is it inverted or not? And that's what that little flag does there. And then the channel is just on that PCA 9685 board, which of these servo channels is this leg connected to. So these are the legs, and then on the next screen, if I just go forward one, I think we just need to press play on that. Nope, we don't need to press play, we just need to get back to the navigator and go to the next one. We can see the foot. So the foot configuration is similar. So there's a front left foot. So as we look at it, this is his front left because we're sort of looking top down, and front left foot is confusing me because I've got the word leg there. I should have changed that to foot, to be honest. That would have made that a lot easier for me to understand and not trip up over my words while I'm speaking. There we go. So again, we want to have a maximum angle of 50 degrees to a maximum angle of 150. So it's going from, I think that's 150 to 50. So you can see it on the screen, it's going from 150 to 50. And that's what that little compass is showing us on the screen there. So we've got another table of trues and falses, maximum and minimums, and these are all 50 to 150, which is nice and easy for us to code in there. So this is all important when we're actually putting the code together, but it's also important to make sure that our servos are kind of aligned correctly. If we put that little white thing, which is the servo horn, I'll show you that on the overhead. If we put this little white thing in the wrong orientation, when we try and move it, if that's already thinking it's at, you know, the maximum 180 degrees, and we want it to go even further, that's not going to work. So it needs to make sure that when we're putting them together, they're in a kind of default position at something like 90 degrees. I usually hope that they're in 90 degrees. So I'll just put him back down there for a minute. Okay, let's get back to our screen share. Okay, so let's start putting the robot together, and we'll have to refer back to these tables as we go. So the first thing to do is just to put everything together. Let's not worry about the actual angles first, and then we can worry about that afterwards, because we can always just unscrew things and adjust them about, and I'll show you some tricks and tips for that as well. So let's go to our overhead. I'll just move my microphone a bit closer to me. Right, okie doke. Let me just check as well how we are doing. There we go. Okay. Just making sure our stream is okay and everything's good. It's looking okay. Okay, so what we'll do is we'll start from scratch. We have our frame, we have our chassis, and this chassis is the version that has none of the lugs on that you'll find on the regular SMARS. They're usually in opposite corners. So we get our frame. It does have an orientation. There is a sort of bit that goes in there. I don't know if you can see that on the camera there, but this is the correct orientation. So it'll fit quite snugly, really quite snugly over the frame, over the chassis, like so. And then it'll go down as far as it can, and it's kind of about there. So the reason that these little indentations are important, that's where the Raspberry Pi is actually going to sit when we take it out of this little case that it comes in. There is a little insert connect, but essentially that's where it's going to sit. So it's quite important that they're the right way around, otherwise it just won't rest in there properly. So last week you might have seen that I put together one of the feet onto a servo, and that this servo goes into this arm. And what I've done just before we went live was just put another servo into one of these servo holders and screwed in the servo horn there as well. So that one is now ready to be connected in to one of these. Now it's important again which way round these go. Now you can see when we have these servo holders, the actual servo horn and the pivot point can either be on the inside, or if we put it that way around, it can be on the outside. Now we want to have the maximum amount of degree of freedom there, so let's have it as far on the outside as possible, because if it's on the inside, and we have a look what that looks like, it would have to be on this side. Actually, would it be like this? We wouldn't get very much degree of freedom there if we had it there, so it'd also be clashing with the foot next to it, so it needs to go on the very outside, like so. And you'll see that there's these little diamond nubs. You can see them, and there's a little diamond hole there as well. And we just need to push these into place, and you'll see it just sort of click when it gets into the right place, like so. And once we've got both of them in place, they'll be quite snug. That one at the moment isn't particularly fitting in well. And one of the tips I would say is super glue. Once you're happy that these things are set up correctly, super glue is your friend. So what we need to do next then is do the next. Yep, so that one's going to go there. Let's push this one into place. It's gone in a bit more snugger than the other one. That's not going anywhere, that's fine. You can see there I've not actually put the servo horn on. So the servo horn is this little white little white bit of plastic you usually get when you buy some servos. I don't know if you can see them there. You usually get a range of about 3. There's like a long one, there's a sort of squarish, a cross-shaped one, and there is also just this singular arm. So this is the one that we're going to use, and this is what these have been designed, this little indentation there in the arm, and when you push them down it'll sort of click into place on top of the servo. And then there's a tiny little screw that will go into, screw that into place. So I've got a nice magnetic screwdriver here. So this is why I did a few of them just before we went live, just so that I wasn't spending the entire episode just screwing things into place, because I didn't think that'd be a particularly interesting video. There we go. Okay, so that's one of them done. We then need to put in place this one, and again I think it makes sense if we've got the wires so that they're sort of pointing up, because we can, what I've done on this one here is I've used some zip ties. I don't know if you can see on there, we've got some orange zip ties, and that one's kind of the opposite way round. So this one I'm going to put them on the top there. So let's just push this into place. This is one I prepared earlier, and the other side we'll completely do on camera so that you can see. These are a very tight fit on this one here. So let's just push that into place there, and it'll just click once it's seated correctly. There we go. You can see there, it's got a nice snug fit. There we go. So we've got half our robot already assembled, and we have 4 servo cables there just dangling off there. Right, so let's do the next side. So I've not done any of these at all yet, and I'll show you some of the things that we need to think about. So if I just get, I'm going to go for that one there next. I'm just checking the orientation. I'm going to get a servo, and when I put these servos into place there, the wire on these, if you can see there's a little bit of plastic that's preventing that from pushing in there, so I actually have to snip that away. So I'll just get some clippers and just do that. Both of them bits hit me in the head then. And that now fits in nice and snug, and we can just work the wire into that little channel and it just pops out there. And the servo should be pushed in nice and snug like that, so that the servo spindle, whatever you call it, is pointing nice and up. Okay, let me just move that so I can see what's going on next. Right, so that's that bit done. So this is going to go into there, so this is going to have this there next. So there is a sort of little lug on the bottom there, and there is a corresponding hole on the bottom there. So what we need to do is push that on first, just so it's sort of in place, and then just lift that over. That's not too difficult to do. And then we need another servo horn just going on the top there. Now say we make a mistake, say we put the servo horn on like that, and then when we push it we realise that's the extent of that motor, it's not going to go any further. How would you get that out there? Now you might think, well, I can just dig it out with a flat bladed screwdriver, but you're really going to ruin the channel that sits in. So a better way is to get one of the screws that you get inside the bag. So you usually get 2, they look like wood screws, they've got very sharp point on them. If you just manually pick the middle hole, oops, let's just do that with a screwdriver instead. We just screw this into the middle hole there, just a couple of turns, not all the way, just so that it's in there. We can then pull that out, and it means that we can do that without damaging the rest of this. And it doesn't really matter if there's a tiny bit. Yes, you can't even see that I've done that on there. It looks fine. So I can set that back to about 90 degrees and then push that into place. So I've done it again there. Let's just get it just into place. I can pull that out a bit. Spin it round to 90 degrees, near enough, and then that's fine. And then we just need to get out with a little screw. These are tiny, tiny little screws, and then we just have to screw that into the top. and that'll just stop it from slipping or falling out. There we go. So now we can push that into place. So you just see which way around that's going to go. That's going to go that way around. That's fine. Let's just push this into place. Usually not too bad on the frame. It's the arms that are the hardest ones to push into place. There we go. And there we go. And what we need to do next is, yep, we need to have the correct foot. So again, I need to trim out that little piece of plastic that's in there. See if that's sufficient. There we go. So now that needs to be, is that the wrong one? Is that the other side? I think that's for that side there, so it's this one here I need to do. No worries. Let's just trim that. Just clipping with abandon. I'll never find the bits of plastic again. Well, I'll probably find them with my bare feet when I'm walking around. There we go. Right, that's now in place. I should have checked that just before I started putting that together. There we go. So that can now push into that. These are the ones that are the harder ones to push into place, just because there's less leverage, because it's so close to that bar there. There we go. Looking good, nice and solid. And what we need to do next is find the correct foot, which is that one, and we just need to put the lug that's there into there, and then just lift that up into there. There we go. Again, let's put it about 90 degrees, put the horn on, and then screw into place. Little screw. Okay, so that's that one done. We then just need to do this very last one. So we've already done one, we've just got the very last bag. Left this one in here just so we can see what they look like as they come out. Nice and fresh. Just want to be, again, unbagging everything and losing all the little screws on camera, so I opened all the other ones just before. So again, we can see what we get in this bag. We get a number of servo horns, and what we want is just that tiny little screw, and the other pieces can just go back in the bag. There we go. So this again needs to be clipped. I think we need to redesign this part for other types of servo. Every type I bought, I think there's only one that I bought that had the same kind that this had been designed for, where it comes out the side rather than the very bottom. It's not a big deal, but it just means there's a messing about required. Right, so what we're going to do on this one is going to be, yep, pushing into there, so let's do that. Okay. Just trying to get it into place there. Okay. And now we need to put quite a seam right that one. Seems to be slightly pointing outwards, it's fine. And we just need to get the arm next. And which way does that go? That goes that way. So the lug goes into that hole there. And we'll just push that over the top, like so. Get our little servo horn about 90 degrees, push it into place, get a screwdriver, push that into the hole there. Okay, nearly done. Maybe I shouldn't have screwed these in, I just need to, because we might have to unscrew them again in a minute. No doubt we will have to unscrew them again in a minute. And this needs to go like so. So just need to find those little diamond notches. Again, this is the hard bit to do because it's hardly any leverage. It's the last one, so last time we have to do this. There we go on that side, and that's done too. Right. Okay, and then we just need to put the last foot on. So again, the notch goes into the hole. And we just need to push that over the top of it. Servo spindle, and then we just need to put the servo horn into place. And then we have a SMARS Quad, very much built. And then it's just a matter of wiring it up to the PCA 9685 board. Okay, there we go. That's looking beautiful. Should have built this for Halloween really, with it being black. So that's what it's going to look like. Okay, so the way that this works, there's a bit of a problem with these board designs. So when you buy these PCA 9685 boards, they have this great big capacitor on them, which apparently is optional, so you can just snip them off like I've done on this one here, and it should still work. And the idea is this is going to go over there, and they're going to sort of peek out. Let's get like so. So that's going to peek out there, and all the server header pins are going to be available to us. Now sometimes these boards come with header pins pointing in the wrong direction, so you can see there they're pointing that way. That's not going to work. So you're going to have to get each one of these very carefully, bend them up with some pliers. I think that's what I've had to do on this one, judging by the angle that they're currently at. So we don't do that just yet. What we need to do first, it's a bit like how you put the rangefinder on. So I always do it the same orientation, where I have it that way round, and it goes into these two little slots that you can see there and there. So that will go into there. It goes about into the middle. Again, very much like how the rangefinder thing works. And then this is the trickier bit. We just have to get that over there and then sort of into place. Okay, so we need to go back to that orientation of which connector goes into which. Let me just find the right page for that. Right, so we go to that one there. There we go. So the very first channel, channel 0. Let me go back onto this tiny little screen here. You can probably see as I do it. Just found one of these pieces of black plastic. So we have the SMARS here. Channel 0 is the very leftmost one, the way that I've got it oriented at the moment. So I need to find the front left leg. So front left leg is this one here on the very top. So let's go back to the overhead so we can see that. So again, channel 0 is here. Front left leg is actually this one here, because that's the foot. So this one needs to go into here. Now they colour coded these. Now they're not always colour coded in this way. You can see there you've got sort of yellow, red and brown. And the way that they designed the servos is quite clever. So the power is always in the middle, so you can never short them out, but you can have them in the wrong orientation. So if you put it back to front, your data is essentially going to ground, and your ground is going to the data. So nothing's going to happen, it's just not going to work. So the orange needs to go to the top, to the yellow, and the brown needs to go to the ground. The red will always go to the middle. So it's quite cleverly designed that. So that's now plugged in there. So the next one is the front left foot, which is this one that's just here. That needs to go in as well, right next to it. Quite a tight fit, these. Then it is the back left leg, which is, have I got them correct? I think I've done that wrong actually. What I've done there is they've kind of crossed over underneath, you see there. So this is actually the one I want. So let's just unplug that first one and plug that one in. This is the joy of doing this. It's very fiddly, and you'll wire it up and you'll think, why is it not working correctly? And you'll just have to figure out, have you actually used the correct cable in the right sequence? So that's now the one that we need to do next. So that's going to go into slot number 3, what is called channel number 2 because it starts at 0. And then we need the back left foot, which is that one. Again, orange always goes to the top. Can you see that there? That's a harder one to put in there because what's happening is it's trying to squeeze into that very narrow gap there. So just have to apply a bit of force there. Possibly just shuffle this about a bit. It's this cover that's causing the issue. It's a very tight fit. There we go. So they're now all level, you see that? All nice and level. And that's the first side done. So we need to do the next, which is, so channel number 4 is the back right leg. So the back right leg is this one, which is just slightly come out of its channel. There we go. So this one needs to go, I always put them over the top so they've got lots of clearance underneath when it's walking. So that's going to go into there. Then we have, I'm guessing it's going to be the back right foot, yes it is, which is this one. Then it's going to be this one, which is the right front leg. And then finally, the right front foot. Again, this might be a bit of a tight fit, but it's not. It's been fine. So you can see there, they're all nice and level. They're all in the back. And what we can probably do is just attach some wire ties to these just to tidy them up a little bit because they are kind of all over the show and it might start tripping itself up. So what might be an idea is to sort of wire tie these together just so that they're connected. And that's what I've done on this one. You can see there the kind of way that I've done that. So I've wired up common ones and then wired them together. I did it in a nice colourful orange cable tie as well. We don't need to worry about that too much. So that is the robot from the wiring up perspective. We can wire up the, I've actually not printed the bit of plastic, the correct piece of so the rangefinder holder, because the one that I should have printed has a little pivot like so. The one I printed is the one that slots into place there, but that's the wrong one. I'm not going to bother with the rangefinder on this one. We're going to use actually a camera for this build, but that'll be next week when I'll be looking at that. I've actually not printed it out yet, but it'll be a standard Raspberry Pi camera, and if I've got one also handy, yes I have, which is just one of these little modules. So that'll be printed into a little plastic holder there, and then this will be able to go. You can get a range of different cables for the Raspberry Pis. This is just the one that comes with the case that's got the camera in it, like so, because when you open these up, you'll need a very short cable. Whereas you can get nice long cables. You can get very, very long cables. The one I have for my 3D printer is about 1 meter long. Anyway, so these things are very easy to sort of connect in. You just need to move that little thing back there, and then you just push that into place like so. and then push it in, and that kind of like locks it into place. So what we need to do next with our Raspberry Pi, we need to make sure that the Raspberry Pi SD card, I've got a little 32 gig one there, I think you can get away with about 8 gigabytes. Why is that not zooming in? And what you'll need to do is you'll need to go to raspberrypi.org and download the memory card image. So let's just have a quick look at that now. Let's see how we do for time. We're doing okay for time, so let's have a look at that. So if I go to my screen share, and let's open up a new window, and let's go to raspberrypi.org. There's the brand new gorgeous Raspberry Pi 400. So what we need to do is we need to download the software. So we click on this little hamburger menu, go to software. Yeah, they're calling it Raspberry Pi OS now. And they've got this Raspberry Pi Imager. And they've got a 40-second video on how to use it. It is very simple and it works for Windows, macOS or Ubuntu. Let's just download it for Windows to see what it looks like. It is a tiny little program. And essentially what that's going to do is burn an image onto the SD card of the latest version of Raspberry Pi. I think they bring a new version out about every 6 months or so. So that's what's going to happen when we run this. It's going to be a little imaging software. So we can actually do that. Not sure how long this will take. Let's have a see. So it's just asking me, do I want to install this? Yes, I do. And I think that's installed now. So let's see. Oh no, there it is. It's the installers there. There we go. Getting ahead of myself. So what's happening just on a different screen there is it's just doing an install of the Raspberry Pi Imager. And what I've got here is just a little memory card reader. And I'm just going to, let's just launch the Raspberry Pi software. I just need to change, share my screen properly so you can see what I can see. So local desktop capture, display one. Let's do the whole desktop. Right, so you're going to see my vMix software there as well, which is just going to look like it's going on to infinity there. Looks very strange. Okay, so let's just cancel that there. That's good. Right, okay, so we have the Raspberry Pi software just here. And what it says is choose the operating system. So we want to have the Raspberry Pi OS 32. And it says choose SD card. Now what I'll do, I'll get, which one shall I choose? Let's just get one out of here that I'm not using at the moment. Do. A number of Raspberry Pis just dotted about. There we go, I'll do that. Well, that's an 8 gig card, that one, just out of interest. So that's just going to go into the little micro SD card reader. And I'm just going to plug this into a free USB slot. I can see that's now activated, so if I now do choose SD card, in a minute it should find that 8 gig card and allow us to flash to it. There we go, mass storage device 7.9 gig, and then right, do you want to wipe everything that's on it? Yeah, whatever, let's just wipe that. So I think it does have to download the software as well, the image, and that might be about a gig or so. So rather than let you watch a really boring, it's like watching paint dry, watching this thing download and write the image, we can go and have a look at one we've prepared earlier. So let me do that. I'll just go to the overhead screen. There we go. So this is one that I prepared earlier. This is the first quad robot that I built. Just move you over a second. And so one of the things you'll need to be able to do with this Raspberry Pi is, so how do you get into it? It is a computer. How do you, sorry, it's just said that there's a partition on there, it can't, right. How do you actually, get in there and start coding it? So it's not like an Arduino where you need to use some software to connect to it. This is like a full-blown desktop computer. That little case that it came in before, you can see when it was in there, it says it's got It's got a HDMI, it's got a USB, and it's got a power. So that's what those connectors mean. And the HDMI cable is quite a bit larger than that tiny little slot. So that's I think it's called a micro HDMI, and you need a connector like this. So you can buy a kit, or you can buy, you know, a few of them, because you might be using a few of these. And you'll need a HDMI cable as well. So let me just get everything out that we need for that. There we go, HDMI cable. So this is just a standard HDMI cable. It's not particularly long, and I'm going to plug that into there. And we just need to plug this into a HDMI monitor. So I have a teeny tiny little HDMI monitor that I use for doing exactly this kind of thing. So it has a HDMI socket on the side there. So if I plug that in, yeah, it's actually on. We can just make sure it's in the correct. I'm actually at the maximum number of connectors that I can currently connect into my vMix solution. Otherwise I would just bring this in as like an extra source. When I tried to do this last week, it just didn't like it at all. So that's the video. We now need to get a keyboard and mouse. So here's a keyboard and mouse, and I also have a teeny tiny little USB hub with a little micro SD, so that can go into there. That allows us to bring in a keyboard and mouse, and the last thing we need is just some power. So I have a cable just here which should allow us to power this. So when I plug this in now, you'll see a little light come on if it's got enough power going to it. I don't think that's happy at the moment. Let me just find, oh, that should work, that should be fine. I can see that the mouse has got power going to it. Now let's just see what happens on this screen. So let's just quickly flick, while that's just messing about, let's just quickly go back to our screen share and have a look. See how the Raspberry Pi is doing. So you can see here, it's about 49%. It takes quite a while for it to burn on there. So we'll come back to that hopefully in a couple of minutes time when I figure this out. So this is not happy about that, so what am I doing wrong there? So that is the power. I just wonder if that isn't sufficient power to drive it. So I do have an official Raspberry Pi power supply somewhere in here. If not, let's see if we can borrow that one there. Let's try this cable instead. Let's try a completely different Raspberry Pi just in case that memory card's duff. It might be that that one isn't working, so let's try this one. It's as if there isn't enough power coming to that, but there should be. Let's try another Raspberry Pi. I've got a whole load of these things. I bought a shed load of these. Let's try that. Yeah, it's as if there's not enough power coming from that. Right, 1 second while I get the... Oh no, that is working. That is working. We can just see the little light flickering there. So When I plug this hub in, it's just going to reset it. It always seems to do that. Let's just do that anyway. There we go. At least we know this particular one's working. There we go. The little green light is flickering on it there, and I can see on the screen there that the Raspbian OS is actually loading up. There we go. It says Raspberry Pi, welcome to Pixel, which was the name of the operating system which is on this particular card. I don't think it's an up-to-date one. Be interesting to see when we load this memory card that's nearly finished now onto that Raspberry Pi that's working there. Let's see what that looks like. Pretty much finished now. It just says writing. Oh, it's verifying now. I think verifying is a bit quicker than writing, but only by about half. So let's go back to our overhead. So we get the full desktop there. You can see we have full desktop experience. There's a nice space on here. You can see there's like a road. You can just about see the mouse moving perhaps on there. If I click on that menu there, you can see the menu sort of dropping down. And what I need to do is just make sure that the Wi-Fi connectivity is working. So it says no wireless interfaces are found, but there is one on it, which is interesting. So let's go on to the Raspberry Pi configuration. Let's just make sure everything's switched on. So I'm just looking at interfaces and I'm just making sure. So on there we've got the camera. We need to switch the camera module on. We need to switch SSH, which is secure shell, and we need VNC, which is virtual network computing, which is kind of a remote desktop, and I think we might need the SPI, because I think SPI is the clock and data, and that I think is it. Serial, we don't need the serial on this particular one. That should do it. So we'll click OK. It'll then have to reboot to put those options into effect. Let's have a quick look on update on how it's going on our screen on the Raspberry Pi. It's about 46% the way through. So this is a good opportunity then to have a look at the comment of the week. So you can see there we had a lovely comment from Sid last week, which said, glad to see you back, because as you know, I'd had some issues with my computer for quite a while, and that meant that I had to take a bit of a break while I put together a computer that did work, which is the one I'm using now. It's a little bit noisy, it's a bit of an old beast, but it's good enough to go live with, bring all these different sources in, and run Windows 10. I did have to buy a new SSD just to have enough space on there, so it took a little bit of time. And also we're building this brand new studio, which you can see behind me. It's sort of slowly coming together. This week we've now got some boxes up there. We've got openCAT in green there. I'm going to illuminate these very soon so you'll be able to see them. We have a white SMARS Quad. We have a face of our InMove, which we'll have a look at in a minute. We have an auto DIY. I think we can do some kind of challenge with the auto DIY versus the SMARS. I think we could do either a race or just to see how fast they move, you know, flexibility, let's see how durable they are compared to each other, and so on. And then at the very end there we have, you can't really see, but it's that Kitronics, and in the very top, you might not be able to see this, is a tiny little Raspberry Pi powered Mac, Apple Mac. Okay, so that's just asking me to reboot. So thank you for that, Sid. I really appreciate the sentiment there. It really is good to be back. I love doing this. And if you enjoy these videos, when I look at the statistics, it always shows me that about half the people that watch it, slightly more than half, don't actually subscribe to the channel. Now, you know, if you enjoy these videos, I'm not asking for any kind of money or anything else. All I do ask is that you subscribe to the channel. That helps me get the channel wider, circulated by the YouTube algorithm. If you do any other interactivities like liking the video or even putting a comment at the bottom, any kind of engagement like that, just rises this video up and gets it sent out further to other people on their watch list. So it suggests to them. So anything like that we can do to help grow this channel really helps me out, because you know, I'd like to get to that 1,000 subscriber mark. It unlocks lots of different options, and you know, that would really help me out if you could do that. So it's a small thing. Just subscribe to the channel. Write me a little note what you think about you know, the new Apple Silicon. Do you think that's a good idea? Do you think they should have stuck with the Intel for compatibility? Because they're going to have to go through that entire thing again, like they did when they moved from the G5 chips to Intel, where they have essentially a fat binary where there's two lots of code, one optimized for Intel, one optimized in this case for the M1, and they have for code that hasn't been split into two, a universal binary, they just have to emulate the old chip on the new one. Usually it's quicker to do that, but it's not as fast as having the native code, so we're going to go through that entire thing again where we get bloated software for a while, so that's fun. But it does mean I'm getting a nice new Apple MacBook Pro. I went for the 13-inch, currently got the 16-inch sat next to me there, but it's a naughty boy at the moment. It's not working as it should do. It's very unreliable, always letting me down, but not all the time, which is the frustration. Sometimes it works fine. Right, so let's have a look at our screen now. We can see we have the software has been successfully written. We can now remove the card from the reader, which I shall now do. There it is, and we can close that down. Okay, let's get back to our overhead. So there's our little brand new flashed SD card. What I will do is I will put it into this original one that we had here. I found that these cards that I bought, these ones that are black, that are not particularly branded, they don't last. Whereas these SanDisk ones tend to last a very long time. So it's worth paying a little bit more. I'm just going to pull the plug on this one. It's worth paying a little bit more and getting what you need. Right, let's see if this is going to work as well. Yep, I can see a little light flash into action there, so it's going to take a second sometimes just to do its power on startup test, and there you go, the little light's flickering. We should see the signal come through on the HDMI as well. Not sure why that's not come through yet. Let's just see if that's going to come through. Wait for it to show me something. Oh, yeah, I can see there's a little flashing cursor there, so that's working, which is good. So this is a brand new, fresh install of Raspberry Pi software. There we go, welcome to the Raspberry Pi desktop, not Pixel. So we know we're on the very latest version. I think it's Buster. Just noticed as well on these little camera modules, there's a tiny little thing there that seems to disconnect. That needs to be plugged into. In fact, that's not going to fix it. I think they've got put this one in place properly. It's kind of like a little bit of glue that glues it in there, and that needs to be pushed into place there, and then that's there. There we go. So I'm very excited to get the Raspberry Pi up and running with Python, because then we can start loading up things like SMARS Lab, and then we can take SMARS Lab to the next level. I've not even written this software yet, but we're going to be writing it over the next couple of weeks, where we can get it to detect faces, we can get it to recognize objects, and then do interesting things with them. It could walk, it could move towards them, move away, you know, walk towards it, walk away, clap, dance, do all kinds of clever things. We've yet to decide what we're going to do with that, but the actual image detection stuff is pretty interesting. Right, so it says, welcome to the Raspberry Pi desktop. Before you start, there's a few things we need to do to set up. Press next to get started. Unfortunately, you probably won't be able to see this very clearly, just because it's a small screen, and I can't actually share this to the other machine just yet. Okay, so it's asking me for the country, the time zone, everything's good. Changing password. Let's just type in password for now. It's a dreadful password, but that'll do for now. It says, does the screen show a black border around it? Yes, it does. So press next. It's now going to scan for networks, so it should find my local network, and there it is. It's going to ask me for a password for that, so just bear with me while I take this off screen for a second and type that in. Okay, and it's now scanning for the an IP address and so on, and I can see the little network things appeared there, which is great. And once it's done that, we can then download Python. Okay, so it's saying update software. I'm actually going to skip that. I'm going to restart it now. There we go. So it's just going to do one last reboot, and then we're good to go. Now, if we can bring in that VNC, I will be able to bring it into vMix, and we'll be able to see it properly. So let me just bring in VNC viewer, and I'll need to type in the IP address once I know what that is. Wait for that to reboot. It's nearly done. It's exciting. We've got a brand new SMARS Quad. Let's move that other one out of the way, and let's bring this one in. I've actually got it plugged into the old one. We can plug it into the new one momentarily. All we need to do is just plug in these 4 wires, 2 which are ground and voltage. So it's just the orange and the yellow. Orange is our data, yellow is our clock. So we can do that once this is pretty much there. So like I said, once I know what the IP address is, I can then go over to vMix and we can bring that in properly, and you can have a look and see what you think. Hey Samo, how you doing? Glad you could join the chat. I'm going to try something. Now that you've made a comment there, I've never actually brought in a comment on vMix. I'm going to see if I can get it to figure out how to do this. View all. No, I can't get it to see that. Let me see if I need to do anything on here. So let's view that. Yeah, there's 2 bits of software that I use for doing live streaming. One of them is vMix, which is a PC only, and then there is one for the Apple Mac, which is Ecamm. And I find Ecamm very easy to use. Just make sure that's all good. However, my Mac isn't working properly, so I've had to learn vMix, which is far more capable than Ecamm. I mean, there's not much difference in the price of them, to be honest. One of them you pay monthly for, Ecamm, and one of them you pay all up front, vMix. Okay, it's just asking me to do all kinds of verification, so let me just go to Gmail on here. Just accept that. I just want to try and bring in the comments, because I used to be able to do this on Ecamm, but I can't currently do it on vMix until I've got this working. So let's try and get this working, and then we can share the comments on the screen and everybody can see what everybody else is saying. So I think I just need to go to mine. Actually, can we do it from this one here? Yes, we can. Great. Yes. So I think at the very back of the, let's see if we can bring this one in. The very back of the room here, I have my iPhone. Let's see. That's an image that was frozen a while ago. I don't know why it's frozen. It should still be working. Let's see if we can fix that as well. We just need to go to change NDI. We should just find the iPhone NDI input. No idea what NDI stands for. Network device interface, something like that. Who knows? Anyway, you can see there on the screen the way that we've got it set up. So I've got a desk, kind of an L-shaped desk, and above the desk is lots of pegboards with all various different SMARS and tools and things. I've got 2 lights and an overhead camera. So my overhead camera is just to my left here, which is where we're working on here, and then we've got the main camera sort of shotgun camera right in front of me just there, so you can just see the camera is just there. That's my iPhone. Okay, so let me see, now we've got that approved. Does that mean we can now view? Just need to click on that to accept it. I can only do this while I'm live, which is frustrating because I wouldn't waste your time otherwise trying to get this working. Okay, right. Let's see if we can see some messages now. So if I click OK, let's see what happens. Okay, that's great. Let's minimize that. Do I need to refresh that? Do I need to close it? Let's try opening that up and viewing the queue. You actually have to view the queue of messages that are there waiting for you. View queue. I can't see those messages. It's so frustrating. Well, we'll probably be going live very shortly with eCam again, which just works. So yeah, Sammy said hi Kev, how you doing? Leroy says hello all. Does a quad have a power switch? It does not have a power switch. One of the shortfalls, I think, of all SMARS robots is by default they don't have power switches, so it is a bit of a flaw in the design. Now, I do happen to have a SMARS version 4, which I'm in the middle of building. It's got the nice little multicoloured wheels on it. I'm going to go for a black and yellow variety because it's going to be one of the ones with the truck or the forklift thing on the front. And what it does have though, it has a little hole, might be easy to see on the overhead actually, it does have a little hole underneath there for a switch, and it has all the mechanisms there for putting a switch into place. There's a little switch holder that just goes in place there. But this doesn't use an Arduino, this uses either a Node MCU or a Raspberry Pi, so it's kind of an upgrade. But it's still SMARS chassis. It has spaces for 4 motors, so we can really power this thing. And interestingly, these things connect to the motors directly, so you've got a much stronger grip there. In fact, if I take one of them out there, you can see there's a little notch there. That's where the motor grabs into, and that just goes into that little place there, and the motor would connect through there. So that's an upgrade to have a switch by default, but the regular SMARS they don't, and the quad doesn't either. So, but I'm going to be using a Raspberry Pi to drive my my quad. So there we go. So now we've got connection to the network, and do we have VNC? Let's just have a quick look to see, do we have VNC enabled? If we do, we can then bring the desktop into vMix, and that makes it a lot easier for us to share what we're actually doing. So I think I just need to select VNC camera, SPI. I think that's everything we need. Okay. And I think it might require one last reboot. If it does, we'll do that, and then we'll just get to the desktop. Let's see if that's going to work. And then we can start playing with Python. I just want to show you how we go about all the different steps that are needed, so I've not missed anything out, because when I did one of the very first videos, I kind of rushed everything a little bit, and what that meant was that, you know, there was huge steps that were missed out, and people didn't know, you know, what this meant. And I was talking about virtual environments for Python, and people were like, whoa, slow down, show me the steps, don't just assume we know everything. So that's why I've gone, you know, downloaded the software from raspberrypi.org, I've flashed it onto a card, we've taken that, we've put it in, we've not missed out any steps, we're doing everything one step at a time. And that's the nature of this video and the series before that. We're building a quad, we're not missing any of the steps out. So I've been contacted by quite a few different people from around the world asking if they can use these in the sort of classroom, in STEM classes, and I'm more than happy for people to use the website materials, these videos, anything like that they find of use. They can slice them up, download them, do whatever. I'm good with that. This is why I do this. So yes, Leroy's saying, please do the SMARS 4 build on the stream. Absolutely. That's why I've not put anything together yet. I've just printed out a lot of the parts, and I've had to order the The little motor driver boards are different, so it doesn't use a shield, it uses a really small little board that fits into the very base, fits into that sort of area just in there. So it's not a special board, it's just a different board that we've been used to. I think I have some similar ones just down here actually. Not quite. Never had them for hand. Never have things to hand when I want them. It's so frustrating. What I have got. There are some other options that we can use for things like this. So you might be familiar with the Arduino Nano. So that's a little Nano, and the board is, let's see if it's got a name on it. It's Funduino Nano it's called. So it says on there, you can get that to focus. Funduino Nano version 3. And it's just a standard Arduino Nano plugged into the board there, and we've got various different headers. I'm not sure if they're servos or if they are something else. It looks like they might be. But yeah, that's one option that we have for things. And then I've got quite a few different varieties of Node MCU. I've not even opened these ones yet. So we open up one of these and show you what this is like. So that's a Node MCU. So there's a ESP826. No, that's an ESP32 actually. So that's quite a powerful one. That will run MicroPython. So one of the things I'm looking at doing as well is how do we run MicroPython on these types of chip? I think this one might be is that the same one? Yeah, that's pretty much exactly the same chip. Yes, it is. And I've got a whole load of other chips very similar to that as well that can run MicroPython. So I was thinking of doing a couple of videos on how do you load MicroPython onto these things. It's a little bit more involved, but that's a Wi-Fi chip. Look at the size of this thing, it's tiny and it can run Wi-Fi. So that opens up all kinds of things that we can do. And the fact that it runs Python means that we could perhaps run SMARS Lab and a whole web interface on a Raspberry Pi, not on a Raspberry Pi, on a SMARS Quad or wheeled version, and that we can do that through Wi-Fi rather than Bluetooth. So lots of options there, lots of different things we can do. Right, let's have a see if we can now connect by VNC to this computer. So there we go, 146 is the magic number. I type in 146 there, does that actually bring us in? Let's see if it does. I did have some issues before with the local Wi-Fi not really seeming to work through the Ethernet. Something wrong with the router somewhere. If that doesn't come in, it's fine. We're kind of a bit pushed for time now actually, so I think that might be a good place to actually break off, because we've done the electronics build. Software and so on is really for next week. So let's get back to our screen share. Oops, not that one, is it? It is. Yes, it says it's timed out there. I'm just trying to connect to that particular thing. Okay, no problem. Let's go back to our presentation. Let's have a look if you can see that without all the other distractions that are going on there. So I just need to change that setting back so it just shows you the browser and not all the full desktop. You don't need to see all that, it's just a bit of a distraction. There we go. Okay. So does that... Kevin, pay attention. It'll be a bit slicker again once I've got eCam. I find this a bit clunky, if I'm honest. I'm sure there's a better way of doing this. So why does it not let me select? There we go. Which option do you want? GDI, OK. Chrome, GDI, OK. There we go. The beauty of software. Why is that not bringing that in now? So yeah, really all I'm just going to cover off is just what we're looking at next week. And I've just messed that up completely now, so let me just go back to that one more time and bring in the full desktop. There we go, because at least you can see something. There we go. Right, so next week we are going to be looking at SMARS Lab. So SMARS Lab is the software that I wrote myself in Python. I wrote it for the SMARS Quad to help set up the SMARS Quad, and then also to make it walk and do things. And one of the criteria I wanted to have was I wanted a web interface. And I'll actually show you the. I've got my book where I designed all the interface and so on. It's actually just a hand. Again, if it's not, we'll look at that next week. And it's pretty much as I designed it. So there's an up, down, left, right, and stand and sit button, and there's some telemetry information on one of the cards at the side, so you can see exactly what angle things are at. And in this particular instance of SMARS Lab, you can just control it kind of remotely, just make it walk around and so on. What I want to do next is enable things like Bluetooth, so that from this one you could potentially control another SMARS, like a wheeled one, or maybe a fleet of wheeled ones. We're all listening to the same Bluetooth channel or something. There's all kinds of options we can do. And I also want to be able to bring in things like the video that it's capturing, so that it can put the little boxes around the faces and objects that it's detected. So I need to get the openCV stuff working as well for next time. So there's quite a few different things that we need to be looking at for next time. But I'm very excited about that. So if you're building along, and if you're up to date with the previous video that we did, where we printed out all the parts, and then you followed this video and you've actually put them together, you'll be good for next week, where we're going to actually load the software using something called Git, which is a source code control software, and we're going to bring in the software SMARS Lab that I've written onto this brand new fresh installation that we've just done now. Onto the Raspberry Pi, and we're going to drive our quad. We're going to make it walk around. So that's going to be really exciting. Before we walk, we have to just make sure all those servos are configured correctly. So I'm going to work on some software this week to make that a lot easier for us to do. Where we can basically just pick a leg at a time and make sure that it's in the correct orientation, and the min and max and the invert, all that kind of stuff is correct. Should be correct if we follow them tables, but sometimes things don't quite go to plan. So we shall see. Okay, so thanks everybody for watching this far. Please again like and subscribe. If you drop a comment, you might be the commenter of the week, so please I encourage you to drop some kind of comment if you're watching this on the replay. And I will see you next time. I'm pretty sure that's everything I needed to cover off before I sign off. I've got a terrible habit of signing off and then going, oh wait, just a minute. Yes, I think that's pretty much everything that we're going to be looking at. So yeah, next week is SMARS Lab. Can't wait to show you that. I'm looking forward to getting into that this week. So see you all next time. Thank you for watching, and goodbye.